of the hotel. So that was briefly the importance of this lecture series. In fact, my tenure as HOD, I have conducted almost 24 series of lectures. And we have specifically chosen the academicians, alumni and industrialists to deliver some of the good topics connected to the chemical engineering profession. Now, this academic year, we are starting with Professor K. Srinivasan sir, who is an emeritus professor from University of Western Australia. In fact, he is alumnus from the same institute. So, I am very happy that under leadership of Kalyan Kumar sir, this legacy of IIChE series will resonate and then start with good momentum. So, this is the first series in this academic year, and in fact, we are very happy that Professor K. Srinivasan sir, all of it with us for almost 4 to 5 months. And the batches, I can say proudly that the present batches of first year to final years are very lucky to have the emeritus professor, because he is a professor at the University of Western Australia, visited so many institutes, and he has a lot of accolades. And that was great because he was global, I can say. We are just limited to our country, but he has visited so many countries. He was given so many talks. So we are all very happy that in fact the faculty also we are very happy. We want to learn something from him. So sir, we are very fortunate to have you, sir. Now I request Deekshita to give a brief introduction about the speaker.
Respected dignitaries on the dais and off the dais, faculty, staff, and my dear friends, a very good morning to one and all. We are honored this morning by the presence of the Honorable Professor K. Srinivasan, School of Engineering, University of Western Australia, Pradesh. K. Srinivasan received the MS degree from Indian Institute of Technology, Madras, India in 1974 and the PhD degree from the Australia National University, Canberra University in 1981. He worked at Research and Development Engineering Manager with Frigate Refrigeration Private Limited, Melbourne, Australia. His main research areas are adsorption, refrigeration, CO2, based supermarket refrigeration and development by cooling technologies for electronic systems. He is a distinguished alumni of College of Engineering Anantapur in 1963 to 1968, organized by IIChE Student Chapter, developed Department of Chemical Engineering, JNTUA Anantapur, Engg, Indian Institute of Chemical Engineering, Hyderabad Regional Center. Thank you.
So now I request Srinivasan sir to start the session.
This is forward. Thank you very much, Professor Dilip Garu, Professor Kalyan Kumar Garu, Dr. Rajshekhar Garu. I am really delighted. First and foremost, I don't think such an elaborate introduction of me required. First and foremost, because I am also I'm still a student. In fact, that's what is going to be my stress on this one. As an HDA, we continue to be students all our life. Even today, I am learning so many things which I did not know. So, I want to thank Professor Kalyan Kumar Garu giving me this opportunity to talk to these young minds who are now assembled here. Because shall we say about 1968, that is about 30 to more than 50 years, nearly 50 years back, 56 years. I was also sitting like you. Only thing that I was, those days we didn't have the projection systems or slides or overhead projectors, nothing of that. All that we have to do is chalk and talk, blackboard. Still we had great lectures from some of the prominent engineers in those days. So as the technology moves forward, we also got to move forward. That's what exactly. Now today the topic actually when Professor Anantapur asked me what is the topic that I want to talk about chemical engineering as a profession. I'm sure all of you are chemical engineers, right? Is there anyone who is not a chemical engineer or who is not intended to become a chemical engineer? No exception. So all of you are chemical engineers or aspiring. So in engineering we have got a saying, all of you are what we call aspiring engineers, that you all want to become engineers. Then once you graduate, you go into a profession. Then you become what is called aspiring engineers. That is, you really work hard to earn your living and make a contribution to your boss or your employer. And the third one, you become what is called inspiring engineers. So when you become a senior boss, or when you become a professor like for a cadet or Hollywood teacher, they inspire the students to do things. Okay, you learn. Then they come to a state where people like me, they are expiring engineers. So we used to be our expiring engineers. So what I want to do is, before I expire, I want to share my concerns about how you can develop profession. If you really take my profession, it is not really a good example of how I manage my profession and all that. I have done something, it's okay, I'm happy about it. Always there's a feeling that I could have done better. So today, chemical engineers, why should you do chemical engineering? All of you joined, I don't know how many of you joined chemical engineering by choice. Can you put your hands up? How many by choice you wanted to become a chemical engineer, so you joined as a chemical engineering department? No one? No one wanted to join the chemical engineering department by choice? No one is raising the hands. So you all been compelled to do chemical engineering. Is that right? Is that how I take it? No one wants to become, not a single hand is being raised. That means you don't want to, you did not come to chemical engineering because you wanted to do chemical engineering. That's really a pity. Not a single person wants to do it by choice. Did you choose when you wrote your CET or whatever, MCET or whatever it is, when you opted for engineering, chemical engineering, did you ask for it, or did your parents push for it, or did your peers push for it, or did you say, no, I want to do chemical engineering? And the whole narrative. Good. They have a half-hearted hand coming up. So, I'm really sorry to see that all the other people who did not raise their hand, you didn't want to become chemical engineers. That's really a sorry state of affairs. Okay, now if you did not want to become chemical engineer, what is it that you wanted to become? Mechanical engineer. How many people wanted to become mechanical engineers? They would, I did not get mechanical engineering. Or they went, I wanted to become a computer scientist, I could not become, that's why I did chemical engineering. How many people are there who were compelled to do chemical engineering, pushed to chemical engineering? No hands are being raised? Okay, this is where I am coming to, later on I will come to that. The most important part is when someone asks a question, you must answer it. If you are not answering, that means you are not valuing the person who is asking the question. So you are not valuing me. Is that correct? So can you please raise the hands who did not want to do chemical engineering but you were compelled to do chemical engineering? You wanted to do say, computer science or electrical, ECE or any branch? No? Not even one person. So there are all the other people who did not raise their hands for becoming chemical engineers and who did not raise hands for not becoming chemical engineers. So there are people are undecided about it. Okay. Now my rest of my talk is going to be only for those people who raised their hands and who wanted to become chemical engineers. How can we become a very professional chemical engineers as soon as we complete? This is what I am going to concentrate on. The other people, if you want, you can snooze off. Okay. What is it that chemical engineers do? When I say engineers, I mean chemical. In general, engineers do so many things like mechanical, electrical, civil, computer science, communication. All the people, everyone, every profession does a contribution to the society, to the well-being. Can you just imagine your life without electricity today? Can you imagine your life without a car? Can you imagine life without even a computer? Can you imagine life without your cell phone in your hand? You can't. Maybe about 60 years back, we did not have cell phones. At least in India, other countries they had it. 100 years back, we didn't have cars. 150, about nearly 200 years back, we didn't have electricity. But still, life now went on. People lived. Life went on. But in the last 200 years, what we call as when the technological revolution started taking place, things moved much faster. Today we are in a better situation what we were about 200 years back, maybe even 50 years back. What makes it possible? Everywhere there is some engineer is having a hand in the development. Everything that you do right from morning, getting up till you go to bed, and some engineer or other has made a contribution to it. Now, if you want to become a chemical engineer, do they do chemistry or engineering? Chemical engineering. Many people, in fact, in our days, we did not have chemical engineering. Okay, we had in our this college only civil, mechanical, electrical, only these three. And whoever wanted to do communication, they had to go to Kakinada because there was some quota was there. Because I am from Anantapur, I did choose communication engineering. Also, I wanted to be a mechanical engineer. I joined here. So whereas chemical engineering was not there, we used to joke about those. That chemical engineer is neither a chemist nor an engineer, which is actually true. Do they do chemistry or engineering, or both are neither? Do they build systems like civil or mechanical engineers do? Do they synthesize or characterize materials like metallurgists do? Or material scientists? Now today they don't want to be called metallurgists, they all want to be called material scientists. So they just talk the part of engineering, they all want to be more of scientists than engineer. Do they develop new medicines like pharmacists do, pharmacologists do? Or do they develop general apps like computer science do? For everything you have an app. I want to go from here, I want to go to a hotel and eat there, the fellow has got an app. Wherever you go, they say you download an app. Now, today all the cell phones are full of apps. At the end of the day, I don't know which app to open. I open the wrong app, and you know that your bank account has been drained by the lakhs of rupees. So that's also you can do. And of course, the apps developers can also do things for positive contribution, and they can also do community work. Now, the answer is that they are capable of doing everything. Anything that is mentioned, they are capable of doing, but they must do what they are trained to do. A mechanical engineer is trained in mechanics. Exactly, you can't ask a carpenter to cook. So similarly, every profession, when you practice a profession, you are going to be trained in that profession. You must have all the skills that are required to practice that profession. Certainly not app development unless it has been directed to chemical engineering. For example, there are so many apps being developed today. If you can download, you want to find out how do you convert the units from one to another, SI units, imperial units. You can download an app. Suppose I want to know what is the atmospheric pressure in Anantapur. There is an app there. And at the same time, there is another app which you want to, most of the time, for properties of air and steam or other fluids, you may have to go to the internet or you refer a textbook. There are some chemical engineers who have developed an app which actually gives you the properties. If you go, everyone got cell phones with you? Everyone has got a cell phone. Okay, open your cell phones. And go for Google. Okay, search for online properties of steam. Online properties of steam, just Google for it and see, okay. So you see how many hits you get. So, has everyone got it? So online properties, so many hits, you take the first, second or third, any of the websites you go there. So there you do the pressure, temperature, it gives all the properties of steam. Now you don't have to go to a textbook or print out, do anything like that. So it is actually, that's done by chemical engineer. So that kind of app you can develop. Similarly, you can do online properties of air. You can you name the fluid that you use in chemical engineering. Every fluid, the properties are available. There are people who are developing apps there. Okay, that you can do that one. And over and above that, quite a few of you, people who did not want to become chemical engineers, what you are looking at is like national careers like IPS, IAS, IAS, IFS and officers, for civil services or military services, things like that. He said, how many people want to go for this one, the civil services like IFS, IPS, IAS? Does anyone have an ambition of becoming a Indian Foreign Service or Indian IAS, or to become a collector, IPS, you want to become a police officer? Is there anyone who wants to become that? Good. Only one person, that's it. 2, 3, 4, 5, 6, 7. That's all. Only 7 people want to go for civil service, the so-called civil services. Do you know what IFS stands for? Indian Foreign Service. Okay. There is also some of them I have not mentioned, but it's called Indian Railway Service. There is also the Indian Audit and Accounting Service. There are so many out there. Incidentally, audit and accounting, though you look at more like a management, accounting business, there is a lot of engineers do audit and accounting. And we'll also look at auditing from the energy point of view that we bit later. So military services, but you have to be trained to do that. When you become an IAS officer, your basic chemical engineering degree doesn't get you an IAS. So what you have to do, you have to go for coaching classes there. You spend another 2 years there, another few lakhs after years you are mom and dad's money, then you try to become that one. Of course, one thing is you see that they say, I have got good power, I have got good money, earning capacity and so on. If you want to do that, you can do. But you remember, most of the IAS, those officers, IPS, IAS, very rarely they use the basic knowledge of chemical engineering they gain with the college. Which actually means that the 4 years you spent in JNTUA college, all the amount of money your moms and dads spent on this one is virtually waste. Because most of those professions, they don't require chemical engineering. If you want to use your knowledge of chemical engineering, you can use it in a broad peripheral way, but not in a detailed way. In my opinion, I should take a profession in which I am passionate about it. And also I should be interested in doing that where my background suits that particular profession. So that's what. Nothing wrong. Because for any of this civil or foreign services or military services, you do require a degree. So if you want to just only do a degree, you could have run any other degree which is a 3-year degree or 4 degree. There was no need to do chemical engineering. But if you do chemical engineering, my first advice, because as a professional body, it is taught by Institute of Chemical Engineers of India, you must do something where you are trained in chemical engineering. Oops. What happened? It is not the last one. This is the last slide.
Few more questions.
This is going back. This one. The one is the third slide. Next one. Okay. So the chemical engineering is a profession which applies the knowledge of physics, chemistry. Most of the people you may thinking that physics is not required or mathematics is required. You do require physics, chemistry, mathematics. These are what we call the core subjects for STEM, science, technology, engineering, and the maths. And then the basic engineering. I said engineering, I didn't say chemical engineering principles. Because you need the basic knowledge of engineering laws. Now, why do you need those laws? In order to design, develop, and optimize chemical process and systems for manufacturing various products across all industries. Now, let me give an example. Right in the beginning, when you get up in the morning and you pick up your toothpaste, okay, the toothpaste has been manufactured in a company where actually there is a chemical engineering involved in it. Okay, and when you have to take bath in the winter morning, like today, it was a bit nippy in the morning, then when you turn on your diesel, the design of the geyser has been done most probably by a chemical engineer there. Or when you go and buy a can of Coke or any other drink, where it is that is being manufactured there, where is it produced, there is a chemical engineer involved in that one. So these chemical engineers design those systems which actually get you into a dining hall or dining table. So chemical process engineering is what are the various products? It can be pharmaceuticals, it can be food, beverage, energy, anything there, mineral processing, anything. Anything that you think of is actually there's a chemical engineer can do the job, not good, he must be, he can do the job. Essentially for the what is an engineer? What is the difference between a chemist and a chemical engineer? A chemist, what he does is he just synthesizes something, okay, now here it is, I've got this salt, I've got this liquid, and you go and do it. It's not that simple. Because when he just synthesizes a particular compound or a chemical or a biological specimen or a vaccine, he produces it in micro quantities, small quantities. Especially if you imagine during COVID, how long did it take to develop a vaccine? But in a country like India, where 1.4 billion people had to be vaccinated, that tiny amount of vaccine that was developed, some